the future of timber harvesting in steep terrain. The T-SKIDDER. Most forest machines in use are not designed for steep slopes. This starts with the anchor points where the traction winch line should be tied. Many are designed for recovery purposes only. This places unusual stress on the frame of the tethered machine. Another problem is the installation position of diesel engines and hydraulic systems. These are not constructed in such a way that they can work correctly on slopes. Major mechanical errors can occur as a result and lead to the complete destruction of the components. The biggest problem, however, is the effect of the various forces. Actually, the rope should provide support, but if the traction winch is not properly placed, you will not be able to steer the tethered machine. How does this system work? The T-SKIDDER drives automatically down the slope to just in front of the shovel loader. Of course, another machine that cuts down trees can also be used. The skidder is then taken over by the operator with the radio and brought into position. The operator quickly loads the T-SKIDDER and sends it back. In order to get the weight more onto the wheels, the driver's cab had to go. This makes the machine lighter and saves many components for the driver's comfort. A big advantage of this weight allocation is that the skidder is now easier to steer because more weight is on the front wheels. The pulling force of the winch now acts directly on the clam bunk with the load. This results in an unconstrained undercarriage, and the rear wheels of the T-SKIDDER follow the front axle, and steering is now possible on steep slopes. After the trees have been loaded, the driver of the shovel loader can concentrate on their actual work again. It would also be possible to install a swing boom grapple instead of the clam bunk. This would make it possible to move the logs down the slope. Since the extraction line is not always straight because of breaks in the terrain or obstacles that simply need to be avoided, the route is recorded the first time it is driven on by radio control. The T-SKIDDER now always follows this route, but it can also be remotely overridden and adjusted or changed. To make unloading the machine faster, the clamp bunk can be tilted to the front. The dead weight of the T-SKIDDER is about 55,000 pounds. We use an FPT engine with 280 horsepower. The exhaust gas regulation depends on the market. The traction force of the wheels is 56,000 pounds force. The maximum speed is about 8 miles per hour. The machine can be controlled with 2 radio systems. A GPS system keeps the T-SKIDDER on a course that can be set beforehand. The built-in components are installed in such a way that they work without any problems, even with a 100% incline. The machine is 23 feet long and is 10 feet wide. The ground clearance is 24 inches. The size of the clam bunk is approximately 22 square feet. This sequence shows the system from a bird's eye view. The T-SKIDDER achieves its best performance when supported by a T-WINCH 40.3, by far the most powerful traction winch on the global market. This machine has a pulling force of 56,000 lbf from the top to the bottom layer of the rope drum. An unprecedented rope speed of 7.5 miles per hour is achievable with this winch. 2 rope diameters are available. A 1 1/8 rope with a length of 2,300 feet is standard, or for added safety, a 1 1/4 inch rope with a length of 1970 feet. This time-lapse slideshow reflects approximately 2 hours of work. In these 2 hours, 18 trips were made, averaging 17 trees per cycle. All these trees were dropped an average of 470 feet away from the landing site. T-SKIDDER, the future in steep slope harvesting.